All right. Thanks, everyone. I've been given this opportunity to talk a little bit about what's the impact of these technologies that we've been discussing here. It has to do with virtual reality, mixed reality, or augmented reality. So Matt and the Meta team had a beautiful presentation to discuss some of the workflows and the use cases. I'm going to be talking a little bit about how we are trying to implement within the phase of construction, and what are some of the challenges, what are some of the opportunities, and give you some quick workflows and also some of the platforms that we've used in this process. So what you see here is our amazing superintendent who is getting trained on how to use augmented reality on a job site. And once we started doing this training, we quickly realized that you got to keep this very simple. Because these folks, they want access to information very quickly and accurately, and if it's taking more than probably 40 seconds, you lose them. So keeping the workflow really simple, user interface really simple, really enables that broader participation within your team. So as I mentioned in the agenda, we'll quickly go through some of the use cases, and I want to start with why do we even care about this technology? What is the value that it brings in within this industry? And in the end, we'll talk about some short-term and long-term hurdles and opportunities. A little bit about myself. As Simge mentioned, I'm the Northwest VDC manager here in the Bay Area for DPR construction. I'm a little shy of a decade worth of experience, but I'm getting there. Some of my recent projects that helped me implement some of these technologies are a few of the data center projects here in Santa Clara. A recent one is a healthcare medical office space that we're building in Santa Clara. And one of the projects that really pushed the boundaries on how we utilize building information modeling was a high-rise oncology lab that we built in South San Francisco. Something common that's across all these projects is really the complexity, what it has to offer, and really how these technologies help us address some of those challenges and communicate the design and constructability in an efficient manner. I'm a hugely passionate about integrating the design way left of the line. That's what keeps me motivated, and always actively seeking solutions that help democratize some of the project information to the project teams, to the right people at the right time. And these technologies help us addressing some of those challenges. While I was thinking about this presentation, there was a recent study that caught my eye, and these were the two stats that I really wanted to share with you folks. This was a study done by Dodge Construction Network in partnership with Dusty Robotics, which said there's only 32% of the field personnel who actually use the building information model. And from a broader project team perspective, only 11% of the field personnel can always access data on what and where to build. Those numbers are embarrassingly low, right? Why is that? What's the challenge there? And there might be a little bit more of a nuance when you dig into those statistics, but right off the bat, that's a bigger challenge that we need to address in the construction industry currently. So just to add a little bit of context, right, when I was thinking about why this is, and in my collaboration with Simge, we talked about what are the current ways that our project team accesses certain information. When you go to the job sites, you see something like this, which we call it as BIM stations, where the field personnel have access to all of your drawings, 3D model, and anything that helps them put work in place. The second way is obviously having access to drawings on your iPad, and also you'll see some very angry people on the job sites trying to fidget around getting to make the model work for them to get that information. It's not really a good sight. So when you draw, again, a commonality between all these solutions, you'll either find them to be bulky, or they're not mobile enough, or it's really unintuitive, or sometimes even there's a steep learning curve to actually learning that software, and sometimes it ends up having delay in accessing that required information. So some or the other way, you'll see these solutions kind of connect to some of these constraints. So what do we do about it? This is a platform that is called SiteLink that we've deployed in our recent project. And what you can see on the right with the video is how easy it is to actually provide access to a 3D model in a 1:1 scale overlaid with the current reality. All that person had to do was just scan 2 QR codes, select the layers, which is essentially the scope that they would want to look at, and that's about it. It gets you access to the information that really matters and everyone cares about in a very easy fashion. We want to keep the interface really simple and easy to use. This person is currently trying to validate some of the in-wall devices and the overhead scope that's coming up in the next week. So this is a really easy way for anyone to get access to that information, right? And you can also see they can quickly jump into non-VR AR mode and really use the model for a little bit more of a detailed information if they want to. How do we get there? So it's a 3 simple step process, right? So you start with setting up the model. That's something that we as VDC engineers and managers do on the back end. And then you start with correlating that model to the real life by placing those QR codes at the job site. And the third and the most important part is finding the champions at the job site that'll really help the team to train and be patient with them to get this technology be a really successful one. So I wanted to just show you what's the effort that it takes on the job site end to actually get this solution rolling, right? So we start with grabbing those QR codes that you saw in the previous slide on how you can attach that in the job site. There's a thumb of rule of like maybe every 10 to 15 feet, you need to have these QR codes placed. And why that the case is, it helps the users control the amount of drift that the model has to offer and the accuracy of that overlay. And what I think the SiteLink here, this platform really shines at is we often hear complaints from the users that the model is not really accurately overlaid, or sometimes the drift is way too much and the reliability is next to nothing. So that's where increasing those number of QR codes and having it more often really helps. And actually a platform like this giving you that feedback to the user really helps you to plan your placement of the QR codes across the floor plan. And you can get even creative. Instead of placing a QR code on the columns, you can have our beloved Dusty robot just lay out the QR code on the floor. So these are some of the workflows that we've implemented to kind of scale it and make it really easy for getting the job site rolling with a solution. And on the back end, setting up the model is really simple. You want to make sure the platform that you really deploy is platform agnostic. And this platform really syncs with ACC, and you can pull in all the models from Autodesk Construction Cloud as individual layers, and you align those QR codes within the model to match up with the reality. And that's it. Those are the 2 simple steps to kind of get that solution rolling. Now what? So now you're really using that solution to help you solve either of these items, which is doing a detailed quality check before something gets installed, or doing a design review like Matt and the Meta team was addressing about to communicate that design intent or design change. Helps with some multi-trade coordination within the job site, where you're giving the right tool to the right people with the right information to make those informed decisions. Enables efficient field and office communication. You'll be surprised how this is still a problem right now. And you can also do some remote and on-site inspections. You can document your change orders and RFIs. Obviously, we can do all of the issue resolutions and efficiently doing our punch list walks. So the list can go on and on. And my point here that I want to make sure we drive away is having a solution that gives that information in a more precise and concise format in an easy way really helps drive that construction process efficiency. Some of the workflow examples that we have done here is using the same platform again. We do something called as quality checks and pre-installation walks with the superintendents and the foreman. This is an example here where we were walking the job for an upcoming scope between our drywall team and our plumbing contractor, where the scope was upcoming for installation, and we found out that the layout of the plumbing cartridge that you see on the right in blue color was the layout was kind of not in alignment with where the drywall framing is supposed to be. This was helpful, and the way we identified that right off the bat was through that AR overlay. And how does this help us? Well, a lot of rework, and we were able to identify the issue way before something is getting installed and fabricated, right? And here what you could see is in the first picture, I highlighted around a pin. They call it a site link pin, and it essentially is a way for you to document what you observed. And once you integrate with your platform, in this case, which is Autodesk Construction, you have a way to make that really transparent across the project members, and they can really track the progress of that issue from when it was identified to when it is being resolved. So again, these solutions are great, but again, making sure that these solutions integrate with the platforms that you have deployed for your project management, and it providing some visibility and transparency is really the key, so that all the stakeholders that are involved are aware of this, and we can efficiently track the progress of it from identifying and it being resolved. Another example here, this was a recent one where, again, we were doing this QC walks, and the layout of the shafts that were supposed to be coming up in our construction sequence was kind of funky, is the way my superintendent told me. So what is the next step? What's the next logical step for anyone to verify the layout, if it's accurate or not? They simply start pulling up a tape measure, and they try to get some measurements of that layout that was done against a constant reference. In this case, it was a shear wall. That's our standard reference. And from this point onwards, they can either do the verification themselves by comparing it to the shop drawings, or pull up the model on their end and try to get some measurements. Most of the time, since we know how busy all the superintendents are, they actually engage a project engineer or a VDC resource and say, hey, this layout is wrong. Can you help me verify this? And from this point onwards, we take that snapshot and try to decode it in a way and give the answer in a binary form of yes or no. If it's yes, then the resolution. If no, we keep moving on. But what I wanted to highlight is here, since not having access to the model here to help him or her verify if this layout is accurate, is actually causing delay in the whole process of getting this installed. So what if we actually gave this power to the people who are putting work in place so that they could make that informed decision? What you're seeing in this is, again, using a function and hardware that's already on your iPhone to actually scan the place, so that you're not relying on a bunch of markups anymore, and you're actually using your LiDAR scanner on your iPhones to scan the space and publish that to the cloud. And then you can actually pull that point cloud data and compare that with the model, all in the same portal, as shown in the image on the right. And now you're really validating the model with the site conditions, and you could really be confident that if the layout is actually incorrect or it's actually good to go. So again, what did we learn through this process? It's really, if you map a simple issue, identifying the issue to resolution in a traditional way, it probably takes minimum 2 to 3 days to kind of get to a resolution, and it involves probably an additional resource. But current and future state with these technologies, and giving the right people the right access to information, probably results in a same-day resolution. So you could really see how these technologies help make that construction process really efficient, and that's really the key. So we want to keep encouraging these platforms and solutions and improve our workflows to get to that point. Switching a little bit into the VR side. Matt and the Meta team pretty much address most of the use cases, and these are some of the snapshots from our recent projects. So some of the use cases that we try to define is like verifying the design intent, like Matt was mentioning about, like looking at the finish and the floor and the use space and how the user wants to feel. So very early on, we get user engagement using these virtual reality environments even before it's built. And it's really critical for both the designer, the general contractor, and the owner if we could lock those early design decisions way left of the line. And similar to conversations from our Meta team here, we have our facility engineer who is actually reviewing the environment to check if there is enough clearance around servicing and equipment. And you could see he is marking up and he's adding comments there saying, hey, we need a minimum of X inches of clearance to really make sure that our service team is good to go. And you're moving away from an intuition to certainty. That's the value that it's really giving us here. You're not really in the hunch mode, but you're really confident about the feedback and what's being built using these virtual environments. And again, just communicating the design intention here, you could see the designer and the engineer and the GC are all in that same environment, walking the space and really getting a feeling of what the space looks like before it's getting built. You're not, again, leaving anything for intuition. Everything is communicated really well and documented really well. It helps, again, with getting those design decisions locked on. And finally, this is something that we did very recently on one of our healthcare projects, which is giving the access to the end user group who are actually performing these surgeries within the operating space, where they can actually feel the clearances that they have around and get a feel of the layout of the operating room itself and make sure they have easy access to the tools that they would need and they're not really bumping into each other. And so this was really critical for us to get some of those layout decisions very early on and not having to modify the design very late in the coordination or construction sequence. So these environments, again, provide huge, huge value in kind of making sure we walk away with certainty. So what do we gain at the end, right? So at a high level, for DPR and any general contractors, communicating those constructability issues and concerns is the key, and these platforms make it really easy for us to do so. And obviously, visualizing all these coordination challenges is kind of like the subset of it. For the designers, it's communicating those design changes, communicating the design intent, locking in those user group feedback effectively. That's really the key that these technologies help us get to. And the owner, of course, benefits from making sure that there is end user agreement. They have a better understanding of the design and construction. They know the facility before even it's built. And they also were able to give those early programming feedback. Overall, these technologies help with better collaboration, better integration towards the design, and better understanding of construction best practices. I want to round up this conversation around what are the things that at least we see within the industry as our short-term hurdles, or rather the opportunities to improve upon, is the first bullet point that I have here is really building the trust in the solution. And that's what's really lacking right now, which is these technologies are great. They look flashy. They have great videos like this. But if the end user is not really trusting the technology, the adoption level drops significantly, and that's very immediate. And how do we build that trust? It's essentially the first problem that I was talking about around the drift of the model, which is really the main concern. And sometimes it's the hardware limitation that we have right now, and sometimes it also has to do with how the user behaves with these technologies. So in our working with the SiteLink team here, we try to develop a way where we could provide that feedback to the user to really tell them how accurate their model alignment is. And what you see here in this video is you could see like there is a green bubble on the top that's circling. And that really is a visual way to tell the user if the model is accurately aligned or not. Make it evident. Give that feedback to the team, and so that they could know, they could be confident about their alignment. So having these kind of workflows really helps build that trust and adoption is is one way to look at it, and that really helps, and we need to keep pushing the boundaries on how we can improve that even more. And then making it really user intuitive is again a key. Like I mentioned, if you're not able to get to this stage where you have the model overlaid in under 30 to 40 seconds, you lose the audience. Because they'll go back to accessing the drawings on their iPad. That's what they're confident about. But really making it easy is the key. And make it really intuitive, keep it simple, and that's what this kind of workflow shows here. Platform agnostic is something really important, not tied to ACC or Procore really helps. Just making sure your solution is platform agnostic really helps. And then access to hypermodel, because that's, again, dependent on how various folks access the information. Some people really look at it from a floor plan to 3D kind of a workflow where they always want to start with their floor plan as a reference, because everyone in construction understands floor plan. They know the grids, they know where they are, and moving them to that 3D model location from 2D to 3D, it really helps. So those are some of the short-term opportunities where we could see that could be implemented to better make this technology even better. Long-term. On the similar side, right, so with the advent of like all of the AI and machine learning and more and more LLM agents that's coming to the industry, when I was really thinking through what could the future look like, it's really accessing that information in a more natural way to the people that are putting work in place. So it could be as easy as a superintendent walking the job site and saying, hey, just tell me the information that I need to know for this particular scope of work, be it the installation of an FSD. It should be an easy prompt that the system understands and pulls the project information accordingly that's relevant to him or her. And having a geolocation awareness. So in this example, I'm thinking they might be having some meta glasses or HoloLens, and it really has a geolocation awareness of the project site and starts actually having those pins around based on what the schedule of the construction is and giving the relevant information. So if it's an MEP coordinator walking the job site and they want to make sure that the FSDs are functioning correctly, the system understanding that and giving that relevant pin of the location of the FSD and highlighting the conduit that connects between the FSD and the panel, that's really powerful. And that's what's going to help. And when I was putting these points together, although I say long-term, and long-term would mean probably 10 years, the amazing part is it's not really that far off. The future is closer than we imagine, because all of this information is within our building information modeling environment, and it's really up to us to push the boundaries and see how we can use our current technology to make this really happen. And all of the team members that are putting this work in place have easy access to it, and they don't have to sit through 3 hours of training on how to access that information. With that, I want everyone in this conference here to walk away with a message that it takes all of us within the industry to make these kind of technologies really successful, and really be patient and put the work and really understand critically what's important for the end user. Thank you.